Right, good morning, grade 11s. I'm sorry that I'm not back. I will be back tomorrow. Miss Jansen told me that she taught you guys how to simplify exponential expressions when you are using prime bases on Thursday, and then you didn't have maths on Friday. So she gave you these two questions for homework, so I just did them. Sorry, I'm still a bit sick, so yeah, that's why my voice is not what it normally is. But yeah, I just did these questions. I wanted us to just mark them quickly and just run through these two questions I did, because the ones we're going to be doing today are different from these ones. So we need to be able to figure out what the difference is between the two. So for this one, number 17, you had 8 times 2 to the x plus 1 times 4 times 2 to the x minus 1 over 2 to the x minus 3. Now, guys, I want you to notice is that at the top, even though we have two separate brackets, what we're actually saying is that we are multiplying all of these together, even though for some reason they've put these two together in brackets and those together in brackets. We can actually just leave those brackets out and just say that we are multiplying these four. This is all one term. So you can add that in if you want to, right? Because that is going to become relevant when we are doing days' work. Here we go. So this is all one term. So what I'm actually doing is I'm just dividing all four of those bases together. Right, I have a 2 or I should rather say all four of these powers I'm going to multiply together. So 8 and a 2 to the x plus 1 and a 4 and a 2 to the x minus 1. And then that whole product, I have to divide by 2 to the x minus 3. Now, I know that Ms. Manson showed you guys this method on Thursday. She sent me pictures of the notes that she did with you at class. So we're going to keep using this method for these types of questions. Guys, when you are multiplying and dividing, like see here we are timesing and we are dividing. That means that we are going to use these two laws of exponents, which we did together in class when I was still there. A to m times e to the n is a to the m plus n. Remember, if you have the same bases and you're multiplying them together, you keep that same base and then you add exponents. At the moment, the only ones with the same bases that we have here that we're actually multiplying together are these two powers. And what about that 8 and that 4? All right, so we can't actually multiply the 8 and the 4 by these 2's because they don't all have the same base. Okay, I could multiply those two 2's, but then I would still be left with an 8 times 4. Okay, then when we're dividing, remember we say that if we have the same base, and we are saying a to the m to divide by a to the m, again with the same base, so keep the same base in the answer, and we're going to say m minus n, so the exponent at the top minus the exponent at the bottom. So these are laws that we're going to have to apply in this case. But before we can do that, guys, we need to get the bases the same. Now, the best way of doing that is to write them in terms of their prime factor bases, because then those will always be simplest. All right, like a 2, 8 you write as 2 cubed, 4 you can write as 2 squared. All right, so this 8 we rewrite as a 2 cubed so that when I have the same basis, I can add exponents. And this 4 we rewrite as 2 squared so that when I'm multiplying them, I have the same basis, so I can add those exponents. Right, once you've done that, you can write all in one line, like I know Ms. Jackson showed you on Thursday rather, sorry. So now you're going to say with these 4 powers at the top, we are multiplying these together. So I have to add all of these exponents. When I'm multiplying, I add. So there you can see my 3 plus my x plus 1 plus my 2 plus the x minus 1. So this is all coming from the top. If you want, you can hide that. When the same color. I hope that the highlighter isn't going to smudge this now. But here from the top, all of that is put together in those terms and adding those together. Right? We are timesing them, so we're adding all of those exponents together. But now, whatever your answer is for the product, we can get if we just add and subtract these like terms, right? But then whatever you're doing there, you have to minus the exponent because we still have the same base, right? If we're adding all of these together, they're all going to have a base of 2, and then you're dividing that by something with a base of 2 again. We can minus that exponent. So the bottom of it, this divided by 2 to the x minus 3 is that x minus 3 that we are subtracting. Now, guys, because there are 2 terms in that denominator, you have to put them in brackets. That's very important. Okay, in my next step, what I did was all the ones that were out of this bracket, I just added and subtracted so long because I could see that I had like terms. So I had 3 plus 1, that's 4, plus 2 is 6 minus 1 is 5. So that's where that 5 comes from. Then I have an x plus x, that's 2x. So that's where that comes from, all right? So you can highlight that in blue again if you want. The 5 plus 2x is actually all of that I simplified. And then what I did was there's a negative 1 in front of this bracket that you're multiplying in, so you get negative x and plus 3. So there's where that comes from. And then in your next step, you just need to simplify. So you have a 2x minus x, which is x, and you have a 5 plus 3, which is 8. Now, because there's an x in this equation, or in this exponent, sorry, you're allowed to just leave your answer like that. You don't need to do anything else, because it's just 2 to the x plus 8. If it was just a number in the exponent, which you'll see now in the next example, then it's a small enough number, then you can just write the actual value of the number. Okay, if there's an x, you can just leave it that. Right, so that was number 17. Number 18, I'll just give you a second just to mark that. I think Miss Jen would have showed you this. If you have this silver calculator, you use the factor button. So if you type in 12, right, and then you press equals, and then you press shift, and then you'll see that there's a button there, and it says fact above that button. That's a fact button. If you press equals, it will give you the prime factor basis of that number. But if you don't have it, it's also fine. You can just think 12. 12 is the same as 4 times 3. You're trying to find the smallest factors, right? So that you work to your prime factors. So 12 is the same as 4 times 3. But then 4 is not a prime number, right? The 4 is 2 squared times 3. Right, so you can do that in your head. It will just take some practice, but you are able to do that. 27 is an easier one. 27 is just 3 cubed. And then 18, again, you can just think, okay, 18 is 2 times 9, right? Not 2 prime number, but 9 is not. 9 is actually 3 squared. So 18 will be 2 times 3 squared. So if you don't have that factor button, and it's not the end of the world, all right, you can absolutely still get the right answer like that. And if you want, you can even like test stuff. So say you didn't have the factor button. If you thought, okay, 12, you can say, what's 12 divided by 2? Sorry. 12 divided by 2 is 6, okay? Now 6 can then go into 6 divided by 2 will give you 3. All right, so it's a 2 and a 2 and a 3. So a 2 squared and a 3. You do it like that. Okay, by just dividing the number by prime factors, which is actually what you guys do in grade 8 when you did those factor ladders. Okay, you can just mark that. I'll give you 2 minutes just to check, and I'll talk through the rest. Okay, so the first step would be to actually identify that you're multiplying and dividing. Now, guys, when you're multiplying these two, a 12 and a 27, those are not the same base. So you can't apply this law unless you have the same basis. So if it's a 12 and a 20, you can't say, okay, I'm going to add my exponents together. You have to have the same basis. Same thing here. When you are dividing by 18 to the 2x minus 1, you can't divide by something that doesn't have the same base. You need to get them to the same basis. So in order to do that, you write them in terms of their prime factors. So 12, we already discussed 2 squared times 3. 21 is 3 cubed. 18 is 2 times 3 squared. Now, once you have that, guys, you're going to apply. So from this step to this step, you are applying this law, that a to the power of m, there's an exponent on the inside of the bracket and on the outside bracket. You guys know that now have to multiply those exponents together. So here we have a 2, and on the outside we have an x plus 1. I have to multiply that 2 by the x and by the plus 1. That will give me 2x plus 2. In the exponent that we have here is 1. So 1 times x is x, and 1 times 1 is 1. Here we have a 3. 3 times x is 3x, and 3 times -2 is -6. Guys, it's very important. It's like you're multiplying this 3 into a bracket. All right, you have to multiply the 3 by the x and by the -2. Next, this 2 at the bottom has an exponent 1. 1 times 2x is 2x, and 1 times -1 is -1. Then we have an exponent of 2. 2 times 2x is 4x, and 2 times -1 is -2. Now we see we have the same bases in some of these cases. All right, we now actually have bases of 2s and 3s. so I'm just looking for a different highlight tick with me. I know where that other one is. All right, we'll use these. So now you're going to take your 2s. And we said we're not actually saying a 2 times in the base of 2. So we're going to add that exponent. We have a 2 divided by another base of 2. So what we're going to do is we're going to have our same base of 2. Then we're going to say the top exponent minus the bottom exponent, and we're going to put a bracket on it. Then for the 3s, here we have a 3 times another 3. So I must add those together, right? X plus 1 plus 3 minus 6. And now we are minusing the exponent of the 3 at the bottom, minus in brackets 4x minus 2. Right, like that. And you want to multiply the answers together, because guys, what are we doing here? We are multiplying, right? At the top we're multiplying, at the bottom we're also multiplying those. So when we're getting our answer, we have to multiply what is left with the base of the 2 and whatever is left with the base of 3. Okay, next step, all I did was I multiplied my -1 into these two brackets. All right, I did the same thing there, -4x plus 2. Then from here to here, you now just need to simplify. So when we're looking at the 2's, we have 2x minus 2, that's 0, and 2 minus 3. Then I have an x plus 3x is 4x minus 4x, that's 0. And then we have a 1 minus 6, that's -5, plus 2 is -3. Guys, here, your exponent of -3, you need to move it to the bottom. And then when you move it, that exponent becomes positive. The 2 to the power of 3, you're not going to move because it has a positive exponent already. Remember, we discussed this last week. Only the thing that has a negative exponent needs to change its position. Whatever has a positive exponent, it stays where it is. So your 2 cubed is going to set the top up. The 3, the -3, moves to the bottom and becomes 3 cubed at the bottom. Now, this is what I was referring to at the top. And I said that if your answer only had numbers in the exponent, then you can just write those actual values. The 2 cubed is 8 and 3 cubed is 27. So the answer here is 8/27. Okay, so that is what you do when you are multiplying and dividing. When you have one term over one term. Right here at the top, we didn't write this down, but I hope we all agree that this is also just one term because it's something multiplied by something else. So this is one term. At the bottom, we also have one term. Now we're going to learn how to simplify exponential exponents with multiple terms. So where you don't only have one term at the top and one term at the bottom, where in some cases you have multiple terms. You guys can just write down. Okay. For this one, we can see that at the top here, we have two terms. But guys, this is making our lives a little bit difficult, because if you go back to where we copied down the exponent law, you should notice there is no exponent law for when you are minusing or adding. You have the same bases and you are actually adding or subtracting the powers. There's no law that. The law that we were using in the previous page was when you are multiplying them, then we have a law, then you can add exponents. When you're dividing them, then you can subtract the exponents. There is no law for adding or subtracting. So what we're going to have to do here is we are actually going to apply an exponent law in reverse, and then we're going to factorize. What I want you to look at here, I actually had it on the previous page just now. We've been working with this law going in that direction, right? Where you have two powers with the same bases and separate exponents that you are multiplying together. Then you can put it together as one base, which is the same base that you start with, and you can add those exponents. But guys, the laws actually work in reverse as well. If you have something like this, you have a power with the base and multiple terms in the exponent, you can split that exponent up, right, into two separate, or however many. If you have 3 terms, you can split that up into 3 parts. If you have 4 terms in your exponent, you can split it up into parts. But in this case, we have 2 terms in our exponent, so we can split this exponent up into 2 bases that are the same as the one that you had with multiple term exponent, and then each term in that exponent can just go with a separate base. I'm going to write it down here underneath. We are going to use that multiplication law in reverse. Sorry, that times mustn't be there. Times must be here. All right, and we're going to apply it to this term over there, 2 to the x plus 2. We are going to split that up into 2 to the power of x, that's the first term in the exponent, and then we're going to change it into times another base of 2 to the power of 2, like that. Right? If I asked you to simplify this, if I gave you this and I said simplify, and all of you would recognize I have the same scissors, timesing, so I'm going to add the exponents and you'll get to that. 2 to the power of x plus 2. Now we're going the other way around. We're actually splitting up that exponent into separate bases. For the second term, my exponent only has one term, right? It's just an x. So I'm not going to split that up. I'm just going to leave it as it is. And at the bottom, I'm also just going to leave that as it is. But guys, at the bottom, I just want to point out that you can't try and multiply this 3 and this 2 together and say that it's going to give you 6 to the power of x. All right, this is not actually a 2. This is actually a variable, 2 to the x, because if x is 1, if x is just 2, if it's 10, it's going to give you diff values for this whole thing. So this is not actually a 2. You are under no circumstances allowed to times this 3 and this 2 together and say that it's going to give you 6 to the power of x. On the side in a little bubble, 3 times 2 to the power of x is not equal to 6 to the power of x. The only time you are actually allowed to multiply bases is if they have the same exponents, and then this doesn't come up often. All right, but if you have if you have 3 to the x times 2 to the x, then you can say, okay, I have the same exponent, so now I can times the base. All right, maybe just do that on the side. But like I said, this doesn't come up often. This comes more often, and it's very common that people think, oh, this is over 3 times 2, so it's just 6. All right, you are not allowed to do that, please. You have to leave it as 3 times 2 to the x. Now, guys, the reason why I did this, right, why I split this phone or this power up, this exponent up, is because do we notice that we still have 2 terms, right? That's still 1 term, and that's still another term. But now we can actually identify a common factor in these 2 terms. We can see that we have a 2 to the x in that term and a 2 to the x in that term. So we're actually going to take that out as a common factor, right? 2 to the x. Remember, we're making out a common factor. We write in front, we open up a bracket, and we divide each term by that common factor. So guys, if I take this term and divide it by 2 to the x, I'm going to be left with 2 squared, which is 4. You are welcome to write it as a 4 straight away if you want. And then minus, now 2 to the x divided by itself is 1. Right, so I am factorizing there. From here to here, I factorized. I'll just put in brackets, common factor. At the bottom, still there's nothing I can do at the bottom at the moment. It's just still a 3 times 2 to the x. I'm going to keep writing it like that. Now, guys, the reason why we factorize is so that we can go from multiple terms to 1 term. Because I hope that none of you were tempted to, in this line, say, oh, there's a 2 to the x and a 2 to the x, let's cancel them out. You're not allowed to cancel out if you have more than 1 term, either at the top or at the bottom, or both. So here you are not allowed to cancel out the 2 to the x's. You are only allowed to cancel out if you have 1 term, which we have now, over 1 term. All right, so that is why we factorize, guys, so that we can go from multiple terms to just 1 term, so that we can actually cancel out. All right, so I'm going to say we factorize 1 factor so that we have 1 term over 1 term. Then, so that arrow means then, cancel out. Okay, actually what you're going to have to do in all of these questions, guys, when you have multiple terms, so when you're adding and subtracting, because we can't use the law where you say, okay, I have the same basis, so I just add the exponent, because that law only works when you are multiplying them. All right, so instead, we split the exponent up. That's your first step. Then we take out a common factor. So let's just highlight that 2 to the x there to show where that's coming from. A common factor that's taken out. And now we have 1 term over 1 term. Now you can actually cancel out that common factor there. That 2 to the x at the top will cancel out the 2 to the x at the bottom. Remember, what are we doing when we're canceling? We are actually dividing. So what I'm actually saying is 2 to the power of x divided by 2 to the power of x is 1. So that's why we are allowed to cancel them out. Now let's just see. Let's look at what we actually have in this bracket. I mean, because now 2 to the x is good. So this is 4 minus 1, which is just 3, right? At the bottom, I've cancelled out that 2 to the x, so I'm also left with the 3 at the bottom. So what is this actually? 3 over 3, 3 divided by 3 is just 1. That is the answer to that question. Okay, I'm going to do one more. Let me just find one here. I don't really have much ones in the next book. I'm going to have to, let's see what they have in the revision exercise maybe. Don't even have any on the revision side. That's odd. Okay, I'm just gonna pause here and just find one in a different worksheet, okay? Okay, I managed to find one on that top worksheet. So this is the next example. You can just copy that down and then we'll do that one. Okay, now grade 11s, this one, I'm hoping that you can see that at the top again, we have 2 terms, right? Because there is a plus in between them. So here we have 2 terms. So now we need to ask ourselves, if we're getting a question like this, we need to see, okay, we're adding. There is no law for adding, all right? So we can't just add and also subtract these exponents now. And what's even worse in this case, we don't even have the same bases in any of them, right? There's an 8 here, there's a 4, and then there's a 2 at the bottom. So what are we're going to have to do there, right? Firstly, we need to think, okay, if I'm adding, subtracting, adding in this case, I need to go from 2 terms to 1 term by factorizing so that I can cancel out. So what did we do in the previous question? The first thing that we did, right, we took the exponents and we split them up. So we can do that again. You can say 8 times 2, 8 to the power of 2x times 8 to the power of 1. So I've split this exponent up into 2x and 1, all right, with this 2 separate bases, plus we can do the same thing here, 4 to the power of 3x times 4 to the power of, now the next term is negative 1. So we actually write like that, 4 to the negative 1. Okay, and that is all over 2 to the power of 3x. In the previous example, once we split our fractions up, or our exponents up, once we split the exponents up into the 2 separate bases, we had the same thing that we could see quite easily, that we could take as a common fact. In this case, we don't. We have an 8, a 4, and a 4. So what we're going to have to do here, guys, is again, we're going to have to work with prime bases, but because we don't have the same bases, we don't have common factors. In order to create common factors so that we can factorize, we need to write these as prime bases. So 8 is 2 cubed, and that was just to the power of 2x, times 8 to the power of 1 is just 8, right? So this one we can just write as 2 cubed. Plus, what about 4? 4 is the same as 2 squared. That is just to the power of 3x. And then this 4 is again 2 squared, and that was to the power of negative 1. At the bottom, we don't have to do anything. It's just one term at the bottom, and it has a base of 2. So we can at least see that we are now heading in the right direction. Okay, now we have bases of 2. So now we could possibly start taking out common factors. Let's just first get rid of all these brackets. So remember, we're applying this law that you have an exponent inside a bracket and outside of a bracket, you multiply those exponents together. So that is what we are doing now. So 3 times 2x is 6x. So that is 2 to the power of 6x times 2 to the power of 3 suppose you could leave that as an 8. Doesn't really matter, but it's fine. Let's just work with those bases. Plus, now we have 2 times 3x, and there's again 6, right? 2 to 3x is 6. And here we have 2 to the 2 times -1 is -2. Okay, at the bottom we have 2 to the power of 3x. All right, now if we're looking at what we have at the top here, we should notice that now we actually do have a common factor. A common factor of 2 to the power of 6x. That's what we want, right? When we are splitting our exponents up, we want that to enable us to see a common factor. And again, when we did the initial split, couldn't see it because these had the bases. So we first had to make the bases the same. So now we're going to take out 2 to the 6x as a common factor. I'm going to be left with not 2 cubed, we can write that as 8. Okay, if you want to keep writing a 2 cubed as well, that's perfectly fine. So remember, when I'm taking out a common factor, I'm dividing each term by that factor. So I'm saying this whole term divided by 2 to the 6x. If I take that away, I cover it up with 8 plus this term, if I take away the 2 to the 6x, I'm left with 2 to the -2. Now, guys, if you want to, you just write that as 1 over 2 squared. I hope that makes sense, right? 2 to the -2. It has a negative exponent, so you would have to move that to the bottom and make that exponent positive. Now, you might remember that I told you to do that. That moving thing only works if you have only one term. So I can't say, okay, I'm going to move this to the bottom here because I have multiple terms. All right. So here you can just do 2 to the -2 on its own is 1 over 2 squared. If you can't do that, you can also use the calculator, guys. A little hint, you can say 2 to the power of -2. What is that? Oh, it's 1 over 4. All right, 1 over 2 squared, 1 over 4, that's just the same thing. Okay, this is now all 2 to the power of 3x. Now we're in a bit of a pickle, because do I have exactly the same at the top and the bottom? I can just cancel out like I did in the previous question. Previous one was easier. We had a 2 to the x and a 2 to the x. We could just cancel them out straight. Now we have a 2 to the 6x and a 2 to the 3x. So now we should remember what I'm actually doing. I'm saying this divide by this. And when we are dividing powers with the same bases, what do we do with the exponent? We take the top one minus the bottom one. So I'm actually going to have 2 to the 6x minus 3x, right? We can't just cancel out straight because we don't have the same thing at the top and bottom. So we need to back to the basis. When we're counting out, what are we doing? We're actually dividing. I'm saying this divided by this. And when we have the same bases and we're dividing, we take the top exponent minus the bottom exponent. Now, what did we have in brackets here? Here we had 8 plus a quarter. Okay, let's simplify. 6x minus 3x is 2 to the 3x. All right. Now, 8 and a quarter. 8 plus a quarter is 8 and a quarter, right? You can leave it like that if you want to. You can write it as 8 and a quarter. But I'm just going to write it in, what's it called? As a mixed number, an equal fraction, sorry. Or you can leave it as 8 and a quarter, all right? Or you could say 2 to the 3x times 8 and a quarter. And guys, from here, there is actually anything else that you can do. All right? You might think, oh, this 2 and that 4 can cancel out. But like I said higher up, this is not actually a 2. This is just a base 2. It has to be, it has to stay attached to that exponent. So you can't say, oh, this 2 and that 4 will cancel each other out. I'm going to be left with a 1 to the 3x. No, you cannot do that. This is actually your final answer. If you want to write this all in one fraction, right? you could rewrite it like this. You could say that 2 to the 3x is 2 to the 3x over 1. And this second fraction that we have is 33 over 4, which you could then just write as 2 to the 3x times 33 all over 4, if you wanted to, but you don't have to. All right. But I know that some people probably don't like leaving it like that. So you could write it one fraction just by multiplying the numerators and multiplying the denominators. But guys, this is a perfectly fine final answer. All right. I am not going to giving you guys hope for tomorrow, because your project is due tomorrow. And I really, really hope that each and every one of you will hand it in tomorrow. Guys, if you are absent tomorrow, please send me an email and attach the typed part to the email, and also take pictures of the hand-drawn part. So your project still has to finish tomorrow. You need to just email me evidence that it is done. And then as soon as you come back to school, you need to hand in the hard copy, because I have to mark on the hard copy. All right. But please, I'm going to say that again. If you are up tomorrow, that doesn't excuse you from handing in project. All right. If you are absent tomorrow, you have to email me evidence of the project being done. You can take pictures of every single page. If you've printed the whole thing out and you just want to take pictures of all the pages, you can do as well. Or you can scan it in perhaps and email it to me as a PDF. However you want to do it, I need to have evidence in my inbox tomorrow that is done. And guys, please do not come me during the math lesson and ask me. You can go to the library, print it. It needs to be ready and complete at the beginning of your maths lesson tomorrow. I think it is in period 3, and then you must hand it. You do have a break for you to me. So please, any printing or anything that you need to do that before you come to maths class. Please, the due time is not at the end of tomorrow. It is during your maths lesson. All right. Thank you so much, Greg Evans. Have a lovely Valentine's Day.